Hey Venko, thank you for joining us tonight for this workshop, Storage Life Migration. The stage is yours.
Thank you, Yvette. So today, the workshop today is about storage life migration. My name is Venko. I'm solution architect at StorPool. This topic was covered by a presentation yesterday by my colleague Buyan. So I'm not going to repeat what was in the presentation. It is the practical. So the presentation was showed how it happens, what are the different options, and today this is a practical session, and we will do some live demo. Again, please, if you have any questions, write them in the chat here, or you can interrupt me also at any time. Just unmute your mic and ask me if you have any questions. So I will not repeat what was in the presentation, just a very brief. In CloudStack, there are two types of storages: primary storage, where all the virtual machine lives and where their virtual drive are, and where is the live data. The important here is that the primary storage can be defined as a zone-wide or cluster-wide. In this demo, we work with zone-wide storages, but there are some differences in the features and the functions that are supported in the zone-wide and cluster-wide storages. Apart from this, they are the same. And the secondary storage, that is, in most of the cases, this is an NFS storage. It is used mainly for templates and storing the snapshots. So this is the code data. Today we will talk about live migration. This means that we will migrate data from one primary storage to another primary storage, and we will see what are the options and where are the limitations, what is the new development, and I hope that we'll be able to I'll be able to demonstrate this slide. So for the demo today, we have this setup. We have one Apache CloudStack management server, two KVM hypervisors called CN1 and CN2. This is from Compute Node 1 and Compute Node 2. They are in the same cluster. And we have three shared primary storages: NFS, Ceph cluster, and StorPool cluster. Also, on each of the two hypervisors, there is a local storage that is also enabled. On the management node, there is a storage plugin that can control the shared storages. So the control of the NFS, actually it's control of the Ceph and StorPool. The Ceph is built into the CloudStack. The StorPool is a separate project out of the main tree of CloudStack, but it's a plugin that is very easily installed. So the hypervisors and the cloud and the storages are in the same zone, so we'll work only with one zone. Local storage is okay. Let me now show the actual setup. So we have one zone. Everything is in this one zone, and local storage is a feature that is enabled at the zone level. So here, when we define the zone, we have a parameter enable local storage for user VMs. And when we have this enabled, then if we go to the primary storages, we can see that for every hypervisor, the local storage is exposed here. So we have a total of 5 storages, one for each hypervisor, one NFS, one Ceph, and one StorPool. And in order to use different type of storages, I have defined multiple service offerings. So when in CloudStack, the way to select the use of a primary storage when you have access to more than one primary storage is to use tags. So on every service offering, we have a storage tag. Let me see, here it is. So I have defined one tag for each type of storage, and there are several. So for each storage type, I have defined a separate compute offerings. So we have a compute offering that is using local storage, NFS, Ceph, and StorPool. Actually, for the local storage, there is another setup that says use local storage. It does not depend on the tag. So this is the setup. And what we will do today, we will define several virtual machines, and we will see how live migration works, when it works, what are the limitations when it is not implemented or it doesn't work, and what are the specifics. So let me show this. Okay, let's first start with defining some virtual machines. So all the virtual machines that I'll create will use CentOS 8 template. And let's first create two virtual machines using local storage. Actually, we'll start with one. So we select a compute offering that is defined to use local storage. We will use all the other settings by default. And okay, you can see here all the input from my test runs. So let's hope this time everything will go smoothly. Yeah. So let's see the virtual machine. So the virtual machine is currently running on CN1. So this is the consoles of the two hypervisors and the management server. So we have three system VMs running here, and this user VM. And if we check this, so we can see that this VM is defined with a disk that is using QCOW image format, and this is the file. So the file is in on the local storage on the hypervisor. And it's interesting to see this. So when you create virtual machines from template, actually it is using, so this image here is the image of the template, this one that starts with 7.9, and on top of it, this is the image that is the virtual disk of the virtual machine that is used baseline base image of the template. So all the data of the virtual machines are stored here, all the unique data, and this is the overlay, overlay. It's based on the original template. So the data that comes from the template is stored in this image, and this is the unique data that is for this volume. So when we create multiple drives, multiple virtual machines that share the same template, that they will use only one copy of this template. And also this allows virtual disk to be created quite fast. We don't need to copy everything. So we see that this will change when we migrate the data. So let's create the other virtual machines. So let's create a virtual machine that is using the NFS primary storage. and this one. Okay, it's starting on CN2. So the disk of this virtual machine is here. Again, it has a source file and it has a backing store that is the image. But in this case, both the QCOW image, so again, it's using QCOW to format image, they are both on the mount point where the primary NFS server is mounted. So let's create a new virtual machine that is using Ceph. We'll select the Ceph. 3 Ceph. Okay. So this virtual machine is a bit different. It starts again on CN2. So this one. So we can see here that the disk is using protocol RBD. So QEMU directly connects to the Ceph cluster using these parameters. And the difference here is that the image type is raw. This means that we are not using QCOW format, and all the functionality of the QCOW that are implemented with QCOW, like cloning and snapshotting and so on, are implemented in Ceph. So this image is a raw image. So this is a raw block device. And the last VM that we'll create, we'll use StorPool. So it's again on CN2. So like in Ceph, let's see, where is this definition? Like in Ceph, the type of the image is raw, but this time we are using a direct access to a block device. So this block device is exposed by the StorPool storage to the hypervisor as a local block device on the hypervisor. But apart from this, from the QCOW point, from the QEMU point of view, it's the same. So it is using a raw block device for the StorPool virtual machine. So let's see what are the supported types of live migration, storage live migrations. So out of the box, CloudStack supports local to local. So you can live migrate with some limitations. You can live migrate one virtual machine from one host that is using local storage on this host to another host that is also using local storage. This type of migration requires that all the data will be transferred, the entire volume will be transferred from from the source local storage to the destination local storage. So it also supports out of the box migration from NFS to local, and with some limitations from NFS to another NFS. So we'll go here in more detail. So all other type of migration, for example, from Ceph to anything else, or from local to NFS or to Ceph are not supported out of the box. So what we have added in our plugin, we have added functionality to capability to migrate live from any type of storage to StorPool, and currently now it's in development to, and soon it will be available to migrate from StorPool to any other type of the supported storages. And if there is interest in the community, we may add also to cover this red part, so we will allow any to any storage migrations. So how live migration works? Actually, it is using QEMU virtual machine migration, and it is done with a Apache CloudStack migrate virtual machine with volume API call. So this will migrate the virtual machines from one hypervisor to another, and during this migration, it will also copy the data from the storage that is on the source hypervisor to a storage that is on the destination hypervisor, and it is not necessary that these storages would be a local storage. So even if it's a shared storage, you can use the same function. So you can define a virtual machine that you use, for example, NFS shared storage, and well, NFS was not a good example. NFS shared storage, and then StorPool shared storage on the destination host. So as a side effect, you need to although you may not need to migrate the virtual machine from one hypervisor to another, this method requires you to migrate the virtual machine. You cannot keep the virtual machine on the same hypervisor, even if you don't need to migrate it. So let's start with this migration, and we will see how it works and what are the limitations. So we will start first with a local to local. So this method, this is the only combination that is possible through the user interface, from the web interface here. So you do just a standard virtual machine migration. You select the destination host, and since this virtual machine is defined to use local storage, it will just use the destination local storage on the destination host, and you don't need to specify the local storage because there is only one local storage on each hypervisor. So the interesting part here is that here will be an error. However, this is an issue with the web interface. If we refresh the state, we will see that the virtual machine is actually migrating. And if we get back here, so this is our virtual machine that's currently migrating to CN2. And we can see the virtual machine with the same ID is currently started here in a pause state. So at this moment, the QEMU is transferring the state of the virtual machines, the RAM of the virtual machine, and the entire storage. So let's check this. So this is the disk. So you can see the difference here. Let's compare them. So on the source hypervisor, the disk is defined with a source file and the backing store, that is the template. On the destination hypervisor, however, this is only one file and no backing store. So all the data is now transferred to a single image, not like in the source hypervisor. So this is a side effect of live migration, of the storage live migration, that the virtual disks are flattened and transferred as a single image. So, and if we check the volume, you can see that the file is now 21 gig compared to on the host, it is only 2 gig the base image and 100 meg the overlay image. So 21 gig need to be transferred between the hypervisors, the full size of the volume. So let's see if it's ready. Not yet. So we can also check. Okay, let's try this. So we can see this drive B is the local storage on the hypervisor. We can see currently the QEMU is writing with 130 megabytes per second, transferring the image. So it will take maybe, yeah, okay, it's ready. And if we get back here, okay, virtual machine now is running on CN2. So it would be nice to show that this was a live operation. I'll show this with the next migration, but this happens while the virtual machine is running. So I'm sorry, I missed to demonstrate this, that the virtual machine was live during the migration. So the next supported live migration type is, let's get here, from NFS to local. The limitation here is the NFS primary storage need to be defined as a zone-wide. If you have it defined as a cluster-wide NFS storage, then this operation is not supported. I'm not exactly sure why this. I guess it's just because this path was not properly implemented, but there shouldn't be any technology restriction to do this. So we will not be able to do this using a web interface. There is no web interface for this function for storage live migration, but we can do this using the CLI. So we will use CloudMonkey for this. And let me see if I have it here. Yeah, this is the command that is used for the API call that will cause transfer of the virtual machine. So we will call migrate virtual machine with volume API call, and we need to provide the following parameters: the virtual machine ID, the volume ID, and the destination storage pool where we want our volume to be migrated, and the destination host ID. Just a second, please. So let's try to migrate this virtual machine. So we will need, just a second, please. Yeah. So we will need migrate virtual machine with volume. Let me check something first. So we'll migrate from NFS to local. So we'll get this virtual machine. Let's check its volumes. So this is the volume, and this volume is currently on the NFS storage. So we will need, for the migration, first we will need the virtual machine ID. Virtual machine ID. Then migrate to, and we need to specify all the volumes that we need to migrate. So if we have more than one volumes, we need to repeat this several times with different indexes here, 0, 1, 2, and so on. And this is the volume ID. Let's get the volume ID. So this is the volume ID. And okay, one command I forgot to do. Let's get first the list of storage pools. So list storage pools with filter. We will need only name and ID. Okay, we need this information and try to again migrate virtual machine with ID. Virtual machine ID. Let's get back here. So we'll migrate this from, okay, this is NFS, we'll migrate it from NFS to local. So let's check this virtual machine because we need to migrate on a different host. So it's now running on CN2. We need to migrate it to CN1. So we'll take on CN1, this one. This is the storage, local storage on CN1. And we need to give the host ID of CN1. So this one, BF. Okay, and we shall see here the virtual machine is migrating. And the disk is on the local storage. So let's show this. So this virtual machine is this IP. Okay. Is it still migrating? Yep. So I'll run IOPink on this virtual machine. So it's still using the NFS. I can recognize it by the latency. About half millisecond is the latency of the NFS service, while the local storage is on hard drive, so it will be much higher. Here it is. So it looks like it already switched to the local drive. No, not yet. So you can see that there is increased latency because of the data transfer. We are still on the NFS now. Well, it might take some time to transfer the entire image, but let's check the rate of the transfer. So, sorry, it's here. Well, there is no activity on this disk. Does it finished? Yeah, it seems it has finished. Yeah, so it's now running on the local storage. You can see the latency is 20 milliseconds, about 20 milliseconds. This is the hard drive latency of the local storage on the hypervisor. So we managed to live migrate the virtual machine from one storage to another. So I will demonstrate the third type from, for example, from Ceph to StorPool. But basically everything is the same. So let's select a virtual machine. This one is running on Ceph. So migrate virtual machine. Virtual machine with volume. Virtual machine ID. So this is right, the correct virtual machine. And migrate to so let's get the volume. So let's check the destination storage pool. This is StorPool. This is the ID. And host ID. So currently this virtual machine is running on host 2. We need to move it to host 1. So BF. Okay. So we don't need this anymore. Before starting the migration, I will open a session to the virtual machine here. Okay. Okay. So again, I will run IOPing here. So now this volume is on Ceph. So this is a very small Ceph cluster, not extremely fast. With it's running on a virtual machine, so it's not the best Ceph you can get, but we can recognize this by the latency here, and we will start migration. So list. Just to check that, yeah, virtual machine is running while the data is migrating. And we can see on the destination hypervisor, so the disk is a volume on StorPool. This is a block device on the StorPool block device on this host. So let's wait for this to complete, but this is so this is how storage live migration works. So there are several limitations. First, as we talk, local to local. One very important note, and thank you, Andrea, about this. So in order for QEMU to support these live migrations here, this path here, you need QEMU version 212, I believe, and it is available in the QEMU KVM EV package from the enterprise virtualization in CentOS. So if you're running your QEMU from the stock QEMU from the base repository in CentOS, this function will not be available, and any of this live migration will not work. So the minimum version is QEMU 212. And also for the NFS to NFS storage. So NFS to NFS storage seems to only work when cluster-wide, let me see, yeah. So only when both the source and the destination NFS storages are cluster-wide. If they're defined as zone-wide, it doesn't work. And the opposite from NFS to local works only if the NFS is zone-wide. If it's cluster-wide, it will not work. So this is a strange limitation, but you need to consider this at the moment. I guess with the next version, all this will be solved, and hopefully all these metrics will be green. There are no anything that will prevent this to be implemented. So let's check. Yeah, I believe we're already on StorPool. Now you can see the latency is about 200-300 microseconds. Let's check. Yeah, the API call is completed, and the virtual machine is now running here. So this is about live migration. What if we need to migrate something, for example, from Ceph to NFS, for example? So the only option is to do offline migration. And for this, you need to stop the virtual machine and then migrate using another API call. Let me see. I think it also supported by the, I'm not sure if it's supported by the user interface. So let me check. Yep. So for example, this one is now running on, where is this? This volume is local. Let's try to, so if we need to migrate this, for example, to Ceph, the only option is to stop the virtual machine. So let's show this. Stop the instance. And then we need to go to the volumes. And now I believe we will be able to migrate the volume. Yeah. So we can now select the destination storage to migrate it, for example, on Ceph. So this should be should run smoothly, so without any issues. Let's try this. So the volume is migrating from local. When it's completed, it shall go to Ceph. So again, we need to wait for the entire 20 gig image to be transferred. With the large images, large volumes, this can be quite significant. It can cause quite significant downtime. And while this is in transfer, I'll show another trick for offline migrations. So for example, if we need to migrate from NFS. So is it on NFS? So this volume is currently on, okay, this is on local storage. Let's create another VM. So I'll create another VM. Okay, let's wait for this one. It should be ready in no, we will create a new one that will use, for example, Ceph storage, and we'll try to migrate it to, let's say, to NFS. So VM5 Ceph. In the meantime, if you have any oh, very nice comment for the that this API call soon will be in the user interface. Migrate virtual machine with volume, so you will be able to do this with everything with through the user interface. Maybe I shouldn't start to tasks on the Ceph cluster. Well, I'm not sure why we're having why it takes so much time to. Okay, the first transfer is completed. Let's check it. So this volume is now on Ceph. And now we shall be ready to start the virtual machine again. Okay, let's okay, I'm not sure why I cannot connect to this virtual machine. 21 running on node 2. Unfortunately, my console here, virtual console, is not working, so I cannot check what's the state of the virtual machine. So it seems I have some issues with the Ceph storage. Anyway, so let's try another offline migration. So this is currently running. No, this is local storage. So let's select some that is running on. Let's create another virtual machine on NFS. Oh, it doesn't matter actually. Okay, so we'll try to migrate offline this volume from currently its own local storage to, let's say, to StorPool. And so let's stop the virtual machine. So it's currently on CN1, and the volume is on the local storage on CN1. And we would like to migrate this volume to offline to, let's say, StorPool. So this applies, what we'll see here, this limitation applies to all volumes except all type of storage except NFS. So when we try to migrate this using user interface, you'll get an error. Here it is, that for this volume we have defined tag NFS. So this is the tag that comes from the service offering. So this service offering says medium on NFS. It is using NFS tag in order to place the volume on the NFS storage. And when we try to migrate with offline migration, this volume on another storage that doesn't have the NFS tag, like StorPool or Ceph or any other, so we'll have this error. The only way I know that you can work around this is to temporarily add this NFS tag, the required tag, to the destination storage. So we can go to the primary storages, go to StorPool, and edit it at NFS tag temporarily, and now go back to our virtual machine, to the volume. So this is the volume that is with compute offering NFS, and let's try now to migrate it to StorPool. Okay, and now offline migration is started, and when it's completed, you can remove the tag on the destination storage. So this is the only way we manage to do offline migrations between storage clusters. Okay, so if you have any questions.
Thank you, Venko, for the demo and for the workshop. So if anybody wants to ask something, just unmute yourself and join the stream.
Or I can suggest that, Yvette, I think the launch is now open already, or a few more minutes, and to join to the other.
The launch is open, and this night we have changed the virtual pub into a lounge. So everybody who wants to join and who wants to make some networking, you can go to the lounge zone. There are several tables supported by our sponsors and exhibitors, and you can choose a table and you can network with some of the people.
Okay, so I'll be there in a few minutes. I'll just we'll go to get a beer from the fridge, and we'll see there.
I think that Venko is really in a hurry to get some beer and maybe some snacks. Okay, see you all in the lounge. Have a nice evening.
Thank you, everybody. See you there.